Greeting everyone. Welcome to today's presentation. RAID combines multiple physical disks using an algorithm to create a virtual disk with greater capacity, performance, and data error tolerance. While it has been a mature data protection standard, the increasing demand for larger disk drives and high-performance applications has exposed flaws in traditional RAID. As disk capacities grow, rebuilding RAID data takes much longer, posing a significant challenge for enterprise storage management. For instance, a traditional RAID 5 on 6 TB disks takes 2.5 days to rebuild. This process consumes resources, hampers application performance, and can lead to data loss. The RAID architecture, in existence for over 30 years, is now undergoing a transformation. The original RAID technology struggles with lengthy rebuild times on high-capacity drives. A new generation of RAID, called RAID-E, based on traditional block technology, is considered a solution to these flaws in traditional RAID. The traditional RAID architecture comprises a specific number of disk drives grouped into a disk group. Some disk drives can be designated as idle hot spares. A storage pool is created to provide capacity for volumes, and the logical unit number is then mapped to the host to serve as the host storage space. This RAID architecture has some limitations. Firstly, when a disk drive in the disk group fails and requires rebuilding, only the member disks of that group participate in the rebuild process. This can create a bottleneck as data writing is concentrated on the spare disk. Secondly, volume data access is confined to the member disks within a disk group. This limits the host's performance because the storage system handles both data access and rebuilding I/O operations simultaneously. As hard drive capacity increases, traditional RAID architectures experience linear growth in rebuild times, especially when using HDDs with over 4 TB capacity, resulting in rebuild times spanning tens of hours. Several factors influence RAID rebuild times. HDD capacity. Larger HDD capacities require longer rebuild times. Quantity of disk drives. More disk drives in a group extend the time needed for data recovery and transfer. Rebuild job priority. Higher priority rebuild jobs speed up recovery but reduce host I/O performance. Fast rebuild. Enabling fast rebuild focuses on rebuilding the used capacity, shortening rebuild times. RAID level. RAID 1 and RAID 10 rebuild faster than RAID 5 and RAID 6 due to their block-to-block replication. The increased capacity of modern drives significantly impacts rebuild speeds, making it the primary factor. However, longer rebuild times are often unacceptable. To address these issues, RAID-E technology has been implemented. RAID-E introduces additional spare disks into a disk group, known as RAID-E spares, distinct from the existing global local and dedicated spares. These spares are distributed across the disk group by rotating them through the disks. When disks fail in the group, the missing data is rebuilt into the preserved spare areas. Since all disks in the set are destinations for rebuilt data, the bottleneck issue of traditional RAID rebuilds is eliminated, resulting in significantly improved rebuild performance. If new disks are added, data in the spare areas is copied to the new disks. RAID-E offers 4 new RAID levels. RAID 5E, with E denoting enhanced, requires a minimum of 4 disk drives, including 1 RAID-E spare disk, capable of tolerating the failure of 2 disk drives. Adding more RAID-E spares increases fault tolerance. RAID 6E requires a minimum of 5 disk drives. RAID 50E requires a minimum of 7 drives. RAID 60E requires a minimum of 9 drives. Now we take an example to describe how it works. The following example is a RAID 5E with 5 disks. 4 disks are for RAID disks, and additional 1 disk is for RAID-E spare. After initialization, data block distribution is as follows. P stands for parity, stands for RAID-E spare, and it is empty now. Assume that disk 2 has failed. RAID 5E is under degraded mode. The spare areas are rebuilt with data from the failed disk drive. This action is called EE rebuild. After rebuilding, data distributed is like RAID 5, and it can tolerate another failed disk drive. As we can imagine, the more RAID EE spare disks, the faster it rebuilds. When a new disk drive is joined into the RAID EE disk group, the data rebuilt in the spare area will be copied back to the new disk. This action is called copy back. After copied back, it is back to RAID 5E, normal state. Rebuild and copy back of RAID 60E is similar as the above. It will not be repeated here. In this RAID E matrix, you can see minimum quantity of each RAID E level and the fault tolerance of each RAID level. Here can also calculate the RAID E usable capacity is. This section will describe the operations of configuring a RAID E pool. Here is an example of creating a RAID E pool. Please enter storage page and click plus icon to create the pool. In pool creation page, please click plus button to select the disk. Select the disks and then click add button. You can select the RAID level and E spare here. Let's choose RAID 5E with 1 E spare. Please be aware that adding more E spares will enhance rebuild performance, but also reduce the capacity in this pool. After that, please select the volume and host group configuration in this pool creation wizard. Here, you can see the RAID 5E pool has been created with 1 E spare. In our RAID E design, we offer the migration function, which allows user to migrate traditional RAID level to RAID E. Please click gear icon and select Migrate Disk Group, and also choose the disks and RAID E level. After completing migrate process, you can see the RAID level is transferred from RAID 6 to RAID 6E. This test provides the comparison of rebuild time and copy back time between RAID 5 and RAID 5E. We assume that the more RAID E spare disks will have less rebuild time. First, we create a RAID 5 pool. After initialization, plug out and then plug in one disk drive. Count the rebuild time with different I/O access patterns. Continue to create RAID 5E with 1 to 48 RAID E spare disks in sequence. After initialization, plug out one disk drive. The RAID E starts rebuilding. Count the rebuild time with different I/O access patterns. Then plug in one disk drive and set it as dedicated spare. It starts copying back. Last, count the copy back time. The rebuild time of RAID 5 with sequential read 256 kilobytes is 40 minutes and 43 seconds. Compared to the RAID 5E with 1x RAID E spare disks, the rebuild time is 11 minutes and 39 seconds. It improves 71%. This test provides the comparison of rebuild time and copy back time between RAID 60 and RAID 60E. The same, we assume that the more RAID E spare disks will have less rebuild time, and RAID 60E will have better efficiency. First, we create a RAID 60 pool. After initialization, plug out and then plug in one disk drive. Count the rebuild time with different I/O access patterns. Continue to create RAID 60E with 1 to 48 RAID E spare disks in sequence. After initialization, plug out one disk drive. The RAID E starts rebuilding. Count the rebuild time with different I/O access patterns. Then plug in one disk drive and set it as dedicated spare. It starts copying back. Last, count the copy back time. The rebuild time of RAID 60 with sequential read 256 kilobytes is 24 minutes and 58 seconds. Compared to the RAID 60E with 1x RAID E spare disks, the rebuild time is 13 minutes and 4 seconds. It improves 48%. This RAID E function is totally free. It won't require any license to activate. The RAID E spare quantity in a disk group as 128 disk drives. As previous section mentioned, select more spare can enhance more rebuild performance, but it will also reduce more usable pool capacity. Please notice that a traditional RAID level can be migrated to RAID E level, such as migrate from RAID 5 to RAID 6E. But RAID E level can be migrated to RAID E level only, which means it cannot migrate from RAID 6E to RAID 6. With the ever-expanding landscape of drive capacities, the demand for efficient data storage solutions has never been greater. As drive capacity grows, RAID rebuild time grows linearly, posing significant challenges in maintaining data integrity and system performance. The more disk drives you incorporate into a disk group, the higher the likelihood of cumulative failures. In this scenario, the impact of drive capacity on rebuild speed becomes increasingly pronounced, often resulting in prolonged downtimes and performance bottlenecks. However, there's a silver lining in the form of RAID E technology. Implementing RAID E can significantly mitigate these risks, offering a smarter, more efficient approach to data recovery and ensuring that your storage system remains robust and responsive even as your data needs continue to expand. We appreciate everyone's online participation. If you have any questions or requirements, please feel free to reach out to us at any